Hello, Azaan.
Yes, sir.
Mm. So in the last class, we discussed the resistivity. Resistivity is also known as the specific resistance, and there is a relation between the length of the wire, length of the conductor, area of the cross section of the conductor, resistivity of the conductor, and the resistance of the conductor. R is equal to rho L divided by A. So you should learn this formula. And resistivity of a particular conductor is constant. For example, for copper, the resistivity will be different. For aluminium, the resistivity will be different. Mean the resistivity depends upon the nature of material. Okay, resistivity depends upon the nature of the material. So basically, we can define the resistivity. It is the resistance of a wire of unit area and unit length is the resistivity. Now we'll solve some of the questions on resistivity. Okay, so this is the question. Um, in this question, they are saying that a copper wire, a copper wire has a diameter of this. A copper wire has a diameter of 0.5 mm and resistivity of 1.6 into 10 to the power minus 8 meter. Okay, what will be the length of the wire? What will be the length of the wire to make its resistance 10 ohm? So you have to calculate the length of the wire, diameter of the wire is given and the resistivity of the wire is given. After that, they are asking how much does the resistance change if the diameter is double. They are saying how much does the resistance will change if the diameter will become double. Okay, so we'll solve this. Okay. So it is given in the question. What is the given? Uh, you can take a wire of copper. Suppose this is the wire. This is copper wire. Okay, they are saying that the diameter of the wire is given. So this is the area of cross section. So means that this value is given. This diameter is 5 mm given. Now from this diameter, we can calculate the area of cross section. Area of cross section we can calculate, and suppose L is the length of the wire. L is the length of the wire. Now area of cross section will be the circular area. This will be the circular area. So we can calculate the area as pi r square. Area as pi r square. So we will have the area. Radius, diameter is 5 meter. So what will be the radius? 5 by 2 mm. 5 by 2 mm. It means it will be 2.5 mm. So we can calculate the radius. So I will represent radius with small r. Radius with small r. So radius will be 2.5 into 10 to the power minus 3 meter. So why I have written this? Because in 1 meter there will be 10 to the power 3 Okay. In 1 meter there are 10 to the power 3 So from here we can find the area of the cross section. So it will be pi r square. R square means 2.5 into 10 to the power minus 3 square. 2.5 into 10 to the power minus 3 square. Okay. So further when you will solve it, you can write it as 22 divided by 7. So it will be 22 divided by 7 multiplied by, it will become 2.5 square, and it will become 10 to the power minus 3 square means 10 to the power minus 6. So basically it will become 22 divided by 7 multiplied by 2.5. 2.5 will become 6.25 multiplied by 10 to the power minus 6. So finally the answer will be, finally you will get 0.1964 into 10 to the power minus 6 meter square. So this will be the area of cross section. Now length we have to find, and what is given? Resistance is given. Resistance of 10 ohm means they are saying what will be the length of the wire when the resistance of the wire becomes 10 ohm. And resistivity is also given. Resistivity means rho is given. What is the value of resistivity? 1.6 into 10 to the power minus 8. So it is 1.6 into 10 to the power minus 8 ohm meter. Okay, so we can apply this formula. R is equal to rho L divided by A. So from here we can calculate L. So L will become RA divided by rho. So L will become RA divided by rho. Okay. So you have resistance of 10 ohm. You have area of cross section of 0.1964 into 10 to the power minus 6, and resistivity you have 1.6 into 10 to the power minus 8. It is 1.6 into 10 to the power minus 8. Okay. So this is 10. So when you will multiply this 10 with this number, so it will be 1.964, and this is 1.6 here. Okay. And here this is 10 to the power minus 6, this is 10 to the power minus 8. So you can write 10 to the power minus 6, and in numerator this 10 to the power minus 8 become 10 to the power 8. Now 10 to the power minus 6, 10 to the power minus 8 become 10 to the power 2. So 10 to the power 2 means 100. When you will multiply 100 with this, so it will become 196.4 divided by 1.6. So basically you can remove the point, and when you will divide this value, so you will get the answer 122.7 meter. So this will be the value of length. So length of the wire will be 122.7 meter. This will be the length. After that, this is answer A. Now answer B. They are saying how much does the resistance change if the diameter is double? How much does the resistance change if the diameter double? So You have to think here. If the diameter will become double, the how much does the resistance will change? So uh, we know that resistance is inversely proportional to area. Okay, resistance is inversely proportional to area. And what is area? What is area? Area is, you can write area as pi by 4 into diameter square, and pi by 4 is constant. So resistance is inversely proportional to 1 upon d square. So if the diameter will become double, resistance will become 1 by 4th. Okay, so resistance will become 1 by 4th, will become 1/4. But here you have to remember, length is constant. Length of the wire will remain constant. So resistance is basically inversely proportional to the diameter square. So if you will double the diameter, resistance will become 1/4. Okay. If if suppose this is the case, resistance is inversely proportional to only diameter, not d square. So if you will double the resistance diameter, resistance will become half in this case. If suppose resistance is like this, 1 upon d cube. So if you will double the diameter, in that case, the resistance will become 1 upon 9 times. Resistance will become 1 upon 9 times. Second question. A 6 ohm resistance wire is doubled up by folding. Calculate the new resistance. Calculate the new resistance. Okay. So for example, suppose this is the wire we have. Okay, this is the wire we have. Initially, the length of the wire is L, and area of cross section of the wire is A. Area of the cross section of the wire is A, and resistance of the wire is R, and resistivity of the wire is rho. Because the material uh, will be same, then the resistivity will same. After that, they are saying this wire is folded up double. So when you will fold the wire double, so in that case, what will happen? Area of the wire, area of the wire will become double. When you will fold the wire to double, so area of the wire will become 2 times. Area will become 2 times 2a, but the length will become half. Okay. So you have just cut this wire and doubled it up. So area of cross section will become double, but the length of the wire will become half. Okay, length of the wire will become half. Now apply. And they are asking what will be the resistance. Suppose R dash is the resistance of the new wire. R dash is the resistance of new wire. Now apply R is equal to rho L by A. So here apply, it will be R is equal to rho L divided by A. Now apply here R is equal to rho L by A. What is R here? R here is R dash. Rho will be same because you are just doubling the wire but not changing the material of the wire. So rho will remain same. Length of the wire is becoming half, and divided by area, area is becoming 2 times of area. it is becoming 2 times of area. So R dash will become rho L divided by 4A. Now what is the value of rho L by A? Rho L by A is R. So rho L by A becomes R. So basically R dash in this case become R by 4. Understanding, Azaan? What is happening?
Yes, sir.
Mm, so what is the initial resistance? So final resistance they are asking. So what is the initial resistance? A wire, a 6 ohm resistance wire. So this resistance of the wire, this R here is of 6 ohm. So you can find the resistance of this wire, that will be R by 4, that will be 6 by 4. 6 by 4 means 3 by 2. 3 by 2 means 1.5. So 1.5 ohm will be the final answer. 1.5 ohm will be the final answer. So in this way, we can solve the questions. Please write down. You have to do some calculation here.
Sir, scroll down, please.
Okay.
And done, sir.
Okay. Done. Complete, Azaan?
Done, sir.
Okay. So now, I'm just asking one question. Suppose this is 2 ohm resistance. This is 3 ohm resistance. This is 10-volt battery. First question I am asking, what is the equivalent resistance? What is the total resistance of this circuit? And what is the current through each resistance? Can you tell me the answer? If
Okay,
you
sir.
know, then
1 minute.
I'm just checking whether you are understanding it or not. It's a very easy question. I will. We will have next topic. This combination of resistance.
Sir, equivalent resistance will be 5 ohm.
Yeah, it will be 5 ohm and current will be 2 ampere through each resistance. Okay, so now we'll discuss the combination of resistances. So basically, there are two combinations. I am not saying there are only two combinations. There are generally two combinations, series and parallel combination. There can be infinite combination. You can connect some resistance in series, some resistance in parallel. Some resistance there will be some circuits you will study in your 12th class that cannot be, you can say, in series or in parallel. That is something different. So we will discuss only series and parallel combination. So first I am starting with resistances in series. Resistances in series combination. So always remember that series combination looks like this. We will take only three resistances. Right now we are only taking three resistances, but this will be valid for n number of resistances. So these are the resistances, and these are the wires. So this resistance is R1, this is R2, this is R3. Always remember this is a single wire. This is a single wire, no? Single wire. There are no branches in this. See this wire. In this wire, three resistances are connected and there are no branches. There are no branches. If suppose a wire is connected from this resistance like this here. So now this is not a single wire. Here is one branch also, this one branch. So that combination will not be a series combination. This combination is a series combination because these resistances are on a single wire. And one more thing is here. In series combination, you can see wire is same. So always remember current through each resistance will be same. Always remember this point. In series, current through each resistance is same. In series, current through each resistance is same. Why the current is same? Because the wire is same. You can see here. Here also the current will be I. Here the current will be I. Here the current will be I. So current will be like this in the circuit. This is positive terminal, negative terminal. So current is flowing from positive terminal towards the, and this is the same current through the each. Okay, I have connected this battery of V volt. Okay, I have connected this battery of V volt. Now the voltage across R1 is V1. The voltage across R2 is V2. The voltage across R3 is V3. So the potential difference or the voltage across the resistances will be different. Voltages will be different. Okay, voltages will be different, but the current will remain same. So this voltage V is divided into V1, V2 and V3. So we can write this V can be written as is divided V1 plus V2 plus V3. Okay. Now this combination of R1, R2 and R3, this combination of R1, R2 and R3, I can replace with an equivalent resistance like this. There is only one resistance. Instead of three resistance, we can just uh, connect one resistance and that will be the equivalent resistance. Okay. And through that resistance, the current will be I. So this will be the REI. So from this circuit, when you will apply Ohm's law, here when you will apply Ohm's law, you can write V is equal to I into RE. So you can write V is equal to current I into RE. RE means the equivalent resistance. What is the meaning of RE? Equivalent resistance. Equivalent resistance. So instead of this V, you can write I into RE. Now, what you can write for V1? We know that I told you that, remember, this is this V is equal to IR. Now for this resistance R1, apply V is equal to IR. What is V for R1? V1, and current is I into R1. So V1 is equal to I into R1. So V1 is equal to I into R1. For V2, V2 is equal to I into R2 because current is same. V3, I into R3 now. So here is I, this is RE now. From here you can take I common. So you will have R1 plus R2 plus R3. Now I and I will be cancel out. This I is cancel out with this I. So what will be the equivalent resistance you will have? Equivalent resistance in case of the series combination R1 plus R2 plus R3. So for example, if you have resistances like 4 resistances connected, then what will be the equivalent resistance? R1, R2, R3 plus R4. If you have n resistances, if n number of resistances are connected in series, are connected in series, then we can write R equivalent is equal to R1 plus R2 plus R3 plus R4 plus R5 plus R6 plus and so on Rn. For example, 9 resistances are connected in series. So what will be the equivalent resistance? R1 plus R2 plus R3 plus R4. And if someone is asking what is the current through each resistance, the current through each resistance will be the total current in the circuit, because total current in the circuit is I, here you can see, and that current is flowing through each resistance. That current is flowing through each resistance. You can see one question, very easy question. A resistance of 6 ohm is connected in series with another resistance of 4 ohm. So they are saying a resistance of 6 ohm is connected with in series with a resistance of 4 ohm. A potential difference of 20 volt is applied across the combination. Means this combination has a potential difference of 20 volt. You can connect a cell of 20 volt. Calculate the current through the circuit and the potential difference across 6 ohm resistance. Means you have to find this V1, you have to find this V1, okay, and you have to find the current flowing in the circuit. What is the current flowing in the circuit? Now, first of all, you should calculate the equivalent resistance of the circuit. What is the formula of the equivalent resistance of the circuit? That is equal to R1 plus R2. And equivalent resistance will be 6 plus 4, that is equal to 10 ohm. Now, 10 ohm. You know that this equation will be valid. V is equal to I into R equivalent. So V is 20. Current you want to find. RE is 10. So from here, what the value of current you will get? 20 by 10. 20 by 10 means 2 ampere current is flowing. And now we know that this 2 ampere current will flow through each resistance. So current I is equal to 2 ampere. Through 6 ohm also there will be 2 ampere current. And through 4 ohm resistance there will be 2 ampere current. Okay. So now they are asking calculate the current through the circuit. So current through the circuit will be 2 ampere. And what is the potential difference across 6 ohm? Now you can easily calculate V1. V1 is the potential difference through 6 ohm. So it will be V1. You can apply V1 is equal to I into R1. What is I? I is 2 ampere. R1 is 6. So it will be 12 volt. So in this way you can calculate. And if you want to find the voltage across 4 ohm resistance, so that also you can find V2. So V2 is equal to I into R2 means 2 into 4. V2 is equal to I into R2, that is equal to 2 into 4, that is equal to 8 volt. Now you can just check 12 plus 8 is equal to 20 also. Cross checking also you can do. Okay, Azaan, understanding?
Yes, sir.
Okay. So you have to remember, what you have to remember? Current through each resistance will be same in series combination, and potential difference is divided across each resistance like this. You can write V is equal to V1 plus V2 plus V3. Okay, write down fast.
Let's scroll down.
Okay.
Done, sir.
Okay.
Done, sir.
Okay. In this question, they are saying draw the diagram of a circuit. Draw the diagram of a circuit consisting of a battery of three cells. So first of all, we should know what is the symbol of a battery. A battery is drawn like this. What is the symbol of a cell? A cell is drawn like this. Okay, like this. This is a symbol of a cell. This is positive terminal. This is negative terminal. A single cell. Combination of cell is battery. If you will combine this battery like this, okay, like this, so this will become a battery. Now it will become a battery. What is this? This is a battery. Okay. So they are saying draw the diagram of a circuit consisting of a battery of three cells of 2 volts. So means there is a battery having three cells of 2 volts. So this is one cell of 2 volt. This is one cell of 2 volt. This is one cell of 2 volt. Okay. So basically this is a battery of three cell. So one cell, two cell and three cell. Positive, negative, positive, negative, positive, negative. Now, so this will become a battery of 2 plus 2 plus 2, 6 volt battery. Now we can write it as a 6 volt battery. So finally it will be a 6 volt battery. Okay. Now this is the battery. Draw the diagram of a circuit consisting of a battery of cell having 2 volt. So this is finished. Each uh, um, uh, each, okay, a resistance 5 ohm, 8 ohm, and 12 ohm, and a plug key. And a plug key. What is the symbol? What was the symbol of the plug key? This was the symbol of the plug key, na? Or this was the symbol also of the plug key. In two ways you can. Okay. This is representing the closed switch. If it is like this is representing the open switch. You can check the symbol. I told you. Plug key. So this is a plug key. Plug key, and three resistances are connected. So we have to draw the circuit diagram. Answer A. So the diagram will be like this. Three resistances first connect in series like this. Given in the question, you can see connected in series. So 5 ohm, 8 ohm, 12 ohm. 5 ohm, 8 ohm, and 12 ohm. Now this combination is connected to a battery and a key. So you can connect a key here like this, or you can connect a battery of this battery. You can connect here. Green color battery you have, and you have connected this with wire, and this battery having the potential difference of 6 volt. This is a positive and this is negative, so you can write negative like this, positive, negative. So this is the complete circuit diagram you have. This is the battery, okay, and this is a plug key. Now read the second question. We do not have time right now, so actually I'm having a next class. So what you will do, Azaan, please take the screenshot. I will discuss the second part in the next class.
Okay, sir.
Hmm. And you should also try the second part by yourself, because you have
Okay.
to do redraw the above circuit diagram, putting an ammeter to measure the current. You should know where the ammeter should be connected. Ammeter is always connected in series, and through the resistors, and a voltmeter to measure the potential difference across 12 ohm resistance. So across this 12 ohm resistance, connect a voltmeter, and okay. And what will be the readings
And
in the ammeter and the voltmeter? Means they are asking. Mean they are asking what is the reading in the volt ammeter. Means current they are asking, and what is the voltage across 12 ohm.